Hello, Mr. Parker here again. In today's screencast, we're going to talk about the metric system, also known and referred to as the International System of Measurement. And this is used across the world, and the reason that it's used across the world is so that we have a common language to speak in. If you think about it, in the United States we speak English, and then we have Spanish, and then you have German and Polish and so on and so forth. But if we try to do an experiment, we're all kind of talking in different languages, it's going to be hard to compare numbers or data to. So what the scientists do is they always use this international system of measurement, or what we refer to as the metric system, to kind of speak the same language. So if we run an experiment here in Downers Grove area, that someone in in Austria or Germany can produce the same lab, come up with the same numbers, and use something to compare to. So the system is based off of 10 or multiples of 10. So we're talking about multiplying every time we go from one unit to the next, or from one system to the next, we're going up by multiples of 10. And the common metric system is bases in physical science are meters, liters, grams, Celsius, and minutes. Okay. Meters we're talking about, we'll kind of look at that in the next slide here, that with meters is referred to as length. Okay, so how long something is, and typically we use a meter stick, or what we refer to as a metric ruler. Most of you are probably commonly used to using the inch, feet, yard. Okay, but if you ever watch like a football game or a baseball game from maybe Europe or Canada, what you'll notice is a lot of things are measured in kilometers instead of feet or yards when they're talking about football or baseball or something like that. The second type is when we measure in liquid. Okay, liquid volume, and they use liters. So if you think about when you get gas, or if you're going to go get gas here in the United States, we go get gasoline by the gallon, whereas in different countries they get it by the liter. If you get like a gallon of milk, in other countries they get liters of milk. So in science we use graduated cylinders and beakers to measure volume. Okay, and you can see on this screen here, this first one here is our graduated cylinder, and here is a beaker. And you definitely need to know the difference between the two. The graduated cylinder we use to measure precisely how much a liquid is in we have. And then whereas a graduated cylinder we would use for not exact measurements, maybe transporting liquid from one area to another within the classroom. The third type of measurement we have is mass, and we use grams. If you think about how we use it, we use pounds, okay, but we don't use that in the metric system. So if you look here, you use a balance, and there's two different types. There's an electronic and more like a freehand scale balance. Now this is the one that we'll typically use in class. Here's the balance that we'll use, and you'll get a lot of experience with that when we do our lab here coming up in the next couple of days. Okay, the fourth type is temperature. In the metric system we use Celsius, and if you think about it, most of you are commonly probably used to using the Fahrenheit as the temperature system that we use. And the last one that we use here is time, and this one doesn't vary any. This is minutes and seconds, or seconds, and that helps us all kind of keep, this is all part of the metric system, the different types that we use, different types of tools or instruments that we use within the science lab in order to get the results and the data that we need. And it allows us by using the metric system to compare to other groups. Okay, so now the problem comes in, if you start thinking about it, is how do we go from different sizes within the metric conversion, like how do we convert from one to the next, one from the base unit to different units, size units. So if we look at it here, okay, you can see on this chart we have the base units that I had talked about, like the meter, the liter, the gram, okay, and then we move towards these prefixes. We have deca, hecto, and kilo means 1,000. So these are the larger units. And over here we have deci, centa, and milli. Now that does get smaller and smaller after milli, but this is as far as we're going to go. And you can see here, so we have meters, liters, and grams, and then we have the different abbreviations for each one of the prefixes as you look at this. Alright, on this side of the base, these items, these prefixes are all larger than the base. So the base here would be, let's say, meters. And we go over here, we have decameters, hectometers, and kilometers. On this side, all of these prefixes are smaller than the base. So we have decimeter, centimeter, and millimeter. Okay, and you can see that here. These are smaller than the base. These are larger than the base. On the bottom, we have a little acronym here that will kind of hopefully help you remember the order. Okay, that kids hate deans because deans call mom. So here you have in the middle the because, that's your base unit. You have deans to deca, hate to hecto, kids to kilo. So you have kids hate deans because deans would be deci, centa for call, and milli mom. Okay, and kind of how we convert from one unit to the next. If we assume that we have, let's say, 1 meter or 1 liter or 1 gram, all right, the easiest way is to kind of multiply or divide, or you just move the decimal point. Okay, so if you're here starting off in the middle at the base, if we start moving to this direction, okay, if we had 1, you'd start moving the decimal to the left. Okay, if you're going from the base here, you move the decimal to the right. Now, if we're starting on the edge, as you can see here on the bottom, it says decimal moves to the left. So if we're in the milli, all right, and we want to go over to the base unit, we would move over the exact number of positions of the bases that we move over. Now, if we're on kilo and we want to get to the base unit, we would go 1, 2, 3 spots. So if we had 1 kilo, we go 1, 2, 3. We move the decimal over 3 spots, and we have 1,000 meters. Okay, and we'll definitely take a little, go through this a little bit in class, going through some examples. But let's just take a look at some practice problems that you can have if you'd like to go through some answers here. Okay, so you have 1 liter equals 1,000 milliliters, and 10 decimeters equals 1 meter. And what you could do is you can go through this and kind of check your answers. Make sure you're doing this right to practice, do a little practice work. Okay, so I hope that this little brief, PowerPoint on the metric system and the basics of it is going to help out. We'll definitely in class we'll do some practice with it. We'll worksheet, and we're actually going to have a lab on this also to follow that will help you out with understanding the moving of the decimal places. So this screencast again was on the metric system and the conversions of metric units.